In this video we're going to carry on looking at driving servos on the ESP32 Wroom. So when you look at this pinout here, when you count up the number of pins which that support pulse width modulation, we have 25. However, the ESP32 servo library that we use will allow you only to drive a maximum of 16 servos on the native pins. Obviously the issue there is when you break the servos out, you're going to have to find a way of powering them. Another alternative library that we will be using on the Merseyside area group demo plank will be a library called Servo easing. So as you can see, servo easing is being maintained on a regular basis, and this servo easing we are going to be using to allow us to have different profiles for moving of servos for the likes of maybe semaphore signals or animation. So a nicer solution might be to use the Sg90. Now this device we have talked about within the Merseyside area group in the past, so I'm not going to go into too much detail here. What we need to do is supply 5 volts, 2 amps power to these 2 pins here. So that is taking the load off the ESP32 and putting it onto this module. Then we need to supply 4 pins from the ESP32. So the first one being ground, and then we need to put the SCL from this device to pin 21 on the shield and SDA to pin 22. We also supply 3.3 volts to VCC, and that then allows us to drive 16 servos from this device. Now these are relatively cheap, and by the time you made a suitable breakout, you may as well buy one of these. So how do we get hold of servo easing? We go to here, and what we can type in is servo easing, and here you'll see the library available for you. I've already got it installed. You will have install here, so I suggest you click that in there. So the next thing we then go to is examples, and if we scroll down, because it's a new library, we can see it's here. Now for the PC expander, we'll go to here, and we've got an expander and a servo. I'll expand that here. Now when you go to here, you click compile. It will throw up an error message. And again, it's to do with the lead pin. So what we need to do, we need to go up to here, and maybe at line 75 we need to put a hash, define, then capital lead underscore built in 2 for what is on the ESP32 Dev 1 board. Then we can compile it again, and now you'll see it has compiled. So we'll now send it to the ESP32. So here we can see the serial monitor and also the servo now going through its paces, and it's worth watching to see what is happening within the serial monitor and what is happening on the actual device. So there you saw the LED blinking as it's using non-blocking code. What you have to remember is these are examples of what you can achieve. So sometimes you will need to make adjustments, but they are ideal for learning from. So one nice feature of the servo easing, it allows us to use the .detach and dot reattach, which basically allows for us to move the servo to a certain position. Once we're happy there, we can detach it, so you're basically not keeping the servo under any load while that is happening. Also then, when it does reattach, it doesn't cause the servo to move violently.